Hey, the average Joe here. Hey, today we're going to look at a project I did a few years ago. It's a campus chilled water distribution system. The software is fantastic in modeling district heating or cooling projects, steam, whatever the case might be on the type of project you have. This was a particular university. There's 50 buildings around here, as you can see. 22 vaults. A vault is kind of, if I zoom in here, you'll just see it's a place where they can put in, that's the letters. Put a little letter on them, and then the vault is how the piping, the valving is in each of those vaults. And then the buildings range anywhere from a 12 to 20 degree delta T in the buildings. So some of the buildings had air handlers where they were able to have large cooling coils, right, and get a greater delta T. Some of them had larger. Overall, the delta T of this whole system is about 15 degrees when it's operating and running. A few other things here. I made the buildings look like they are from the top view. I just grabbed our little drawing over here to the side and put that box over the imposed load. So you'll see that imposed load. That's what I can click on, that imposed load, and see a 15-degree delta T, see the load in that. Uh, so that's kind of what's under all these little buildings is just an imposed load that you can click on and see. Then it's all hooked up to an air-cooled chiller, so I can come back here and I can look at that air-cooled chiller, click on it. Under our summary load, I see every building, the identification there. The load in those, right, goes down. That's what makes up that BTU load there. There's about 400 to 800 tons on this project. And then the overall, like I said, delta T is about 14 degrees, 15 roughly. I can click on the pump as well right here, and it's going to show me that associated pressure drop path going clear out to the farthest building. On this particular project, we modeled all the buildings. They wanted to know, some different data about the system. And then they looked at, hey, can we add some piping through this area and reduce the head out to the farthest out buildings way out there. This is hundreds of acres of campus there. So the reason the air-cooled chiller is there, like I say, is just to summarize the load. Then I created 4 chillers over here. I put the load that the air-cooled chiller seen on everything, added that over there to impose load of the whole campus, then put the chillers in with the heat exchanger for free cooling, hooked up the cooling tower, and now I had the model of the central plant in the simplistic way to show that. A lot of times when you kind of break the project up, it helps to calculate it faster. Anyway, I hope this has been helpful. You can do this, whether it's a campus or just a bunch of buildings that are close to each other in some complex, and start looking at, and then also with the scenario manager down here in the bottom, you'll see I had a summer cooling, a free cooling, and you can, the different scenarios, you can easily turn buildings on and off and see what the effect is on the system, maybe how they operate at different times. So, hey, thanks for watching. We'll talk to you later.